Hey guys, I had this humidity sensor that I got back in 2023 before I started doing all these sock videos, and I had heard that you could check the calibration, check how accurate these humidity sensors were by comparing it against the percent humidity of a saturated salt solution. So that's primarily what I was doing with this experiment, but it got me thinking, could I calculate an unknown solution's total dissolved solids? So that was the point. So let's try it. Let's look at it together. So to do this, I want to generate some data points on both sides and generate like a linear relationship. So I had my zero total dissolved solids from the distilled water. I had my saturated salts, sodium chloride, on the other axis, and then the unknown, which is going to be the San Jose municipal water, somewhere in the middle. And we're going to calculate what that total dissolved solids were from its relative humidity value that we get out of this humidity sensor. So that's the concept. So what is relative humidity? Basics. Let's say you had a closed container. You put a cup of water. The water is like little magnets. Usually they got cohesion to each other, but as they bounce around, some of those water molecules will escape the bulk solution and they'll float up into the air and become water vapor. But this is a temperature dependent activity, because if you're below the boiling point, water is going to evaporate into the air and then some of it's going to condense. All right, reaching some equilibrium. If you're at 100% relative humidity, if you add any more water vapor, it will condense out. And so when you add particles to that bulk water, it affects this relative humidity value. So those particles also act like little magnets. They restrain the water molecules from escaping, so it takes more energy to escape, and then it can also get in the way. Like, think again like a magnet. The water molecule can come by, there's a particle there, and it like prevents it from passing. Especially as you add more and more of those particles, the water gets blocked. So this tends to decrease the percent relative humidity, because for that given temperature, the water should have escaped, but instead it got blocked. So you'll see lower percent humidities. Okay. So very simple setup here. We have our closed container, we have our solution, and we have our humidity sensor. And this was a Govee. That's what I was trying to look at for the accuracy. And I waited 4.5 days-ish. Take a little bit of time. Here is the first 6 hours. Left side being percent relative humidity. Those are the solid lines. And the right side being temperature. Those are the dotted lines. The percent relative humidity did not start at the same point for each of the solutions, so unfortunately you can't really compare the rate of change, but you can kind of see about 6 hours they level out. And here is a couple days. Now we're on when we're on the order of days, you can see the temperature fluctuations of my apartment, right? And then you can see the temperature dependencies of percent relative humidity, because that shows up as fluctuations there as the temperature changes. I captured the endpoint values in this table. So let's look at the data. First off, how good is our humidity sensor? Literature says when you have a saturated sodium chloride solution at 20 degrees Celsius, you should see 75.5. We got 74.8. And that's off by 0.7% relative humidity. That's pretty good, given that the humidity sensor itself says that the sensitivity is going to be plus or minus 3%. Being off by 0.7, very respectable. Let's start looking at if we can calculate our unknown. We know what the answer is going to be, or supposed to be, because the city of San Jose has already calculated for us in their water reports. Now, can we calculate that value? Let's do a linear relationship to see if we get 430. For simplicity, we'll just assume that all the temperatures we collected were at 20 degrees Celsius. Saturated salt solution, 357,000 parts per million, which we found a percent relative humidity of 74.8. And then we have the distilled water, where we're assuming it has 0 parts per million of any dissolved solids in it. And we found a percent relative humidity of 97.8%. So now we got our high and low to make this linear relationship. Final minus initial, that gives us the slope. Y equals ms plus b, that's our typical linear formula. Calculate for the y-intercept, and bada bing, bada boom. If we input our unknown into this calculated formula, we get an answer of 4,660 parts per million for the San Jose water. Ooh, completely wrong. But let's try something different. Raoult's law. So this formula, say you had sodium chloride, it dissociates in sodium and chloride. That's usually what the I value is here for particle dissociation. Let's make that I a correction factor for all of the unknowns, all of the air that makes up this experiment. And this Raoult's law, it's normally meant for low concentrations. But you know what? Let's just use it. See what happens. And if we do the math, first we calculate the I value that incorporates all of our error in it. So we say it's 3.06. Then we plug in our San Jose tap water with our percent relative humidity to calculate the parts per million. And that gives us 27,200. So it's even more off. What are our learnings here? First off, humidity sensor accuracy was pretty good. But still, plus or minus 3% for the total tolerance of the sensor. It just does not have precision or accuracy needed for these total dissolved solids calculations. We weren't really controlling that temperature that well either. We might be getting 0.5% relative humidity differences, just with like 1 degree fluctuations. That's not good. We're assuming everything's sodium chloride, but we know that real tap water's got other dissolved solids in there, like calcium. So that also affects the math. And these linear approximations, we had the whole range there. But if you're trying to calculate an unknown, you probably want to be closer to what that unknown is when you do a linear relationship. We also use Raoult's law, which is meant for very diluted solutions, not saturated solutions. Lots of assumptions, and as we see, it didn't really work out. So should you use a humidity sensor to calculate total dissolved solids? I would say no. Not if you're looking for a very precise answer. You could probably discriminate like seawater from like salty water. All right, things to keep in mind. Take care.